Hello students, welcome to mathematics class. Students, this is part 5 of the chapter factorization, in which we are going to discuss questions from the exercise 14.2. Coming to the question number 1 of the exercise 14.2, this contains 8 sub questions which shall solve any 2. In this, 1, 2, 3 and 5, 4, they are all of the same model. Let me solve here. Question number 3rd. In the question number 3rd, 25 m square plus 30 m plus 9 can be written as 5 m whole square plus 2 times of 5 m into 3 plus 3 whole square, where you could check 2 into 5, 10, 10 into 3, 30, 30 will come, 30 m, 5 m whole square is 25 m square and 3 square is 9. Now, it looks like a square plus 2ab plus b square, which is factorized as a plus b whole square. Since using this standard algebraic identity number 1, where a as 5m substituted, b as 3 in this substituted, we can write 5m plus 3 whole square is the factorization of 25 m square plus 30 m plus 9. So, you need to write splitting that in the form of standard algebraic identity, and that is an important skill. Now, coming to the next question, children, I will take question number 6. In question number 6, you could see 121 b square minus 88 bc, it is 88 bc plus 16 c square, which can be written as 11 times b whole the square, which gives 121 b square minus 2 times of 11 b into, so it becomes 22 and we are left with 4 times c plus 4 times c whole square gives us 16 c square. Now, it looks like a square minus 2 times ab plus b square, which can be further factorized as a minus b whole square. By using this second standard identity, we can compare this 11b is substituted as, where a is 11b and here in this identity b is 4c. Thus, 11b minus 4c whole square in this a minus b whole square, by substituting a value and b value, will get this as the factorization of 121 b square minus 88 bc plus 16 c square. This is how they are to be solved. Children, rest of the 6 questions you try to solve. If you do not get, don't be panic, you can ask me, I will solve them and make a video and post it in your WhatsApp. Okay, in your class WhatsApp groups I'll post. If you find any doubt, you can raise a question. Then coming to the main question number 2. Again we are asked to factorize. Here all these are based on the identity a square minus b square, which is factorized as a plus b into a minus b. This is a standard algebraic identity number 3. So we use this one in all of these cases. So let me solve amongst them. Second one I will solve for you, and then fifth one I will solve for you. You can even solve rest of the questions. Certainly 7th is important, 8th is important. I have already solved of this model. You can attempt once. If you find out, do ask me. Coming to the question number 2. In 63 a square minus 112 b square. First of all, you will get doubt that is 63 is a square number? Certainly no. 63 is not a square number. Then how come this 63 can be converted into square number? So you know, whenever you get doubt like that, factorization of 63, prime factorization I am taking. So 3 21s are 3 7s are. You have in 63 3 into 3, which is a square number, into 7. In 112, again by doing prime factorization, 2 5s are 2 6s are 2 2s are 2 8s are, then 2 14s are, and 2 7s are. You have got in the 112 7 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. That means here total 16, which is a perfect square, multiplied by 7. That means I can take out 7, which is a common. The moment I take out 7 as common, this becomes 9a square minus 112b square becomes, where 7 into 16, that 7 gone out, left over 16b square inside. Now it is very easy, children. 7 times of this 9a square, I will write it as 3a whole square minus 16b square, I will write it as 4b whole the square. Now 3a whole square minus 4b square looks like identity 3, standard identity 3, where a is 3a and b is 4b. Therefore, the prime factorization of given algebraic identity 63 a square minus 112 b square is 3a plus 4b multiplied by 3a minus 4b. So totally we have got 7 one factor, 3a plus 4b another factor, and 3a minus 4b third factor. Okay, so this is the very important one. Now coming to the question number 5. In question number 5, see, in the standard algebraic identity a square minus b square, which is factorized as a plus b into a minus b, a can be anything L plus m, b can be anything L minus m. If I substitute back in that, here a is L plus m, b is L minus m. If I substitute, L plus m whole square minus of L minus m whole square will be sum of L plus m added to L minus m into L plus M minus L minus M. Now remove this bracket. If I remove the bracket, L plus M plus L plus minus M plus removes the bracket, so minus comes as it is. So minus M plus M cancels. In the second one, after removing bracket, L plus M minus into plus L minus into minus M becomes plus M. That means plus L minus L cancels. It gets you 2M, it gets you 2L. So 2L into 2M gives you 4LM. So this is the factorization one way of the fifth important question. Okay. So we need to say quickly through which algebraic identity it can be solved. Rather expanding L plus M whole square, later L minus M whole square, after that subtracting, finding, finally the answer is 4LM only. Okay. Now rest of the questions you do as a homework, don't worry, ask me whenever you get doubt, whatever in whichever the question. Coming to the main question number 3. See, we are asked to factorize this. There are 9 sub questions in it and each question is different from the other. You need to identify one by one what technique will help you to factorize it. In ax square plus bx, x is common, so I took it out first, so it becomes ax plus b. So can anything taken away further? Nothing. So this is the factorization of first one. Similarly, in the second one, in 7p square plus 21q square, 7 is common, so I took it out 7, it becomes p square plus 3 times q square. Further, can I take out anything common? Nothing. So that's it. This is the factorization of second one. Similarly, you need to identify each one of them, whether they can be factorized by taking away something common factor. Technique number 1. Is there a regrouping technique can be applied? In 9th one we will apply regrouping technique. For example, in 6xy plus 4y, 2y is common from this 2 plus 6 minus 9x. So from this I will take away 2y common, so 2y of 3x minus 2. Again in this, if I take out plus 3 common, it becomes 2 minus 3x, whereas this is 3x minus 2, this is 2 minus 3x. So I have to take out minus 1 common, it becomes 2y times of, let me do it in next place. So 6xy minus 4y plus 6x minus 9x, I have already factorized as by taking 2y common, 3x minus 2 plus 3 taken out common, 2 minus 3x. So to have the same fellows, I have to take out minus 1 common, so that minus 3 comes, that minus 1 comes out and multiplies plus 3. So minus 3 times of 3x minus 2. Here you have got 2y into 3x minus 2 as it is. Now 3x minus 2 is common. So 3x minus 2 multiplied by 2y minus 3. So this is the factorization of given 9th algebraic identity. We did it by regrouping technique. So we need to decide what technique can be used and how it can be further carried. So it's very important how much you practice, how well you will understand the concept. So rest of the questions you try on your own, you fall back to me whenever you get doubt. Coming to the main question number 4. See children, here powers are all in force. So it is something like a square minus b square, which can be further factorized as a plus b into a minus b. This little advance if we take out, I will have a power 4 minus b power 4 can be factorized as a square plus b square into a square minus b square. Further, this a square minus b square can be further factorized as a square plus b square comes as it is, and this becomes a plus b into a minus b. So, whenever we have got powers as 4 and there is a minus symbol like this, this is one more standard algebraic identity which you will be learning in class 9th. So, based on this knowledge, they gave this question. So, you have already done first question. So, a power 4 minus b power 4 is factorized as binomial a square plus b square multiplied by binomial a plus b, and it is multiplied by third binomial a minus b. Similarly, this p power 4 minus 81 can be written as p power 4 minus 3 to the power 4, which is factorized as p square plus 3 square into p plus 3 into p minus 3. So, I use straight away this identity where 3 square is p square plus 9 times of p plus 3 times of p minus 3. So, this is the factorization of second one. So, little use your brain wisely and make this 3 questions and attempt first. Whatever the doubts you have, I will help you. Coming to the question number 4. Let me solve for your sake question number 5. I am writing a power 4 minus 2a square b square plus b power 4 as a square whole square minus 2 times a square into b square plus b square whole square. It looks like same x square minus 2xy plus y square, which is factorized as x minus y whole square. I can change the standard algebraic identity a plus b whole square or a minus b whole square with another letters also. Here you could see where x being a square and y being b square substitution. So, x square minus 2xy plus y square, where x is a square and y is b square. Thus, we have a square minus b square whole square being the factorization of given. But a square minus b square whole square can be further written as a plus b into a minus b, but whole square, which is nothing but a plus b whole square into a minus b whole square. Children, this is the factorization of given fifth one. How I got this a plus b into a minus b whole square? Because of the factorization of this a square minus b square, I got a plus b into a minus b and whole square is there. Suppose if you have got 2 into 3 whole square, which you can write as 6 square, that is 36. It can also be done as 2 square into 3 square. 2 square into 3 square, nothing but 2 square is 4, 3 square is 9. So, 4 nines are 36, that also gives. So, we have laws of algebraic identities, laws of exponents. Laws of exponents helps you here. In 7th standard, what you have learnt, that helps you. Okay. Here one of the important law, 2 into 3 whole square can be written as 2 square into 3 square. Similarly, a plus b into a minus b whole square can be written as a plus b square into a minus b square. That is how I have written this. Okay. So, I have solved question number 1, question number 2, question number 5. Rest of the 2 questions you solve them. Coming to the main question number 5. Children, in main question number 5, you have got 3 sub questions. Let me solve one by one. Here p square plus 6p plus 8. Here a plus b is equals to 6 and a into b equals to 8. We are using x plus a into x plus b, which is written as x square plus a plus b times of x plus a into b. So, using fourth standard algebraic identity, which is generalization of 1 and 2, 3, I am using here. Here a plus b, sum of two numbers is 6, product of two numbers is 8. So, 8 can be written as 1 into 8 or 2 into 4. Sum of 1 and 8 cannot be 6, but sum of 2 and 4 is 6. So, they suits well. That means I say a equals to 2 and b equals to 4. Thus, p square plus 6p plus 8 can be factorized as, here variable is x, so I have got x plus a. But whereas in the given question variable is p, so I will write it as p plus 2 into p plus 4 is the right solution, is the factorization. So, is the factorization. Now, coming to the another question, let me solve now question number 3. Okay, this I am giving as homework for you. In this question, further again I will write x plus a into x plus b, where it is the factorization of quadratic identity or quadratic algebraic expression x square plus a plus b times of x plus a into b. Using it, where the sum of two numbers is 6 and product of two numbers is minus 16, where 16 is the product of 1 and 16, 2 and 8, 4 and 4, anything else? Nothing, that is it. So, sum of 1 and 16 is 17 or their difference is 15, so it won't suit. Sum of 2 and 8 is 10 and difference of them is plus 6, okay, it suits. Sum of 4 and 4 is 8 and difference is 0, so it also won't suit. So, this only suits. But should I consider a as 2 and b as 8, and what is positive, what is negative? Now, see, if I consider a as 2 and b as 8, I want their sum being positive 6, that means a is negative, b is positive. Why? Because here sum of two numbers is positive, that means bigger number is positive, smaller number is negative, that is it, simple logic. Thus, I will substitute here p square plus 6p minus 16 for the factorizing it as p minus 2, because a is negative. So, here variable is x, so I have taken x plus a. Here variable is p, so I have taken variable p. So, p plus of minus 2, p plus of minus 2 becomes p minus 2 into p plus 8, because b is 8. By substituting, it is the factorization. See children, this logic of thinking is very important. Okay, which identity you are using and what is the reason behind choosing a as 2 and b as 8, and why a is negative and why b is positive. This logic of choosing is very important. Okay, so with this I will wind up this session. So, question number q square minus 10q plus 21, which is the second one, I am giving as a homework for you, do it on your own. So, Take care of yourself. Jai Hind. Thank you.